In this video, we'll briefly go over ROS message types, also known as ROS2 interfaces. In the last lectures, we made a publisher and subscriber which uses the string message type from the standard messages package. However, there will be a lot of instances where we want to use other message types to process data in a more organized way. Let's head over to the ROS wiki page to see what messages entail. So here it says ROS applications communicate with messages, services, and actions. You should remember these concepts from the ROS2 overview lecture. Now, the part of this to pay attention to is section 2. So here it goes over the message description specification. So here it says message files are found in the MSG directory of a ROS package. So if we look back at our VS Code editor, we can see we are including the standard messages ROS package. We are going into the MSG directory to find the corresponding message header, which in this case was string. Going back to the docs, we can see an example of how a message file in ROS is organized. Essentially, it is just a basic type available in computer programming associated with a name for the data. This simple example uses an int 32-bit type and has an attribute called myInt, followed by a string attribute, which they called myString. So you can have multiple attributes in a custom message declaration. But ROS comes with so many default message types, you will most likely want to take advantage of them. So let's take a look at the standard messages library, which we use to get our string message type. So this is the ROS index site. This is where you can find information on some readily available ROS packages. So here we are on the standard messages ROS package page. If we scroll down, we see a README, which gives us a description, and down below, we have more types to choose from. This includes booleans, floats, and even some arrays of those basic types. To use them, all we have to do is add it to what is imported in our C++ code. So, for example, let's import in the boolean and float64 messages from this same package into our C++ subscriber file. Alright, and with that, we've imported in different message types, so if we wanted to create more publishers or subscribers that use these different types, we could do so. Now there's one more thing I want to point out while we are here, which was when we printed out our hello world message in the subscriber callback, we called message.data. Well, if I head back to the ROS index page, we can click on the link for the string message type. So here we're taken to the GitHub source page, which in this case acts as an example, but we can see the string message type has an attribute type string, and the attribute name is called data. This is how all the messages in the standard messages packages are organized. And this is just because messages are meant to be flexible so they can have multiple attributes, as we saw in that example custom message file. So I'll go back so that we're back on our main page, and back at the example like we saw, you can have multiple declarations of different types with different attributes. Let's take a look at another set of commonly used ROS messages used with robots called sensor messages. So I will go ahead and scroll down. Here we see a lot of useful message types to use with common sensors you would put on a robot. For starters, you probably want a camera on your robot to see what is going on. Here, the image and compressed image message types would be useful, as they efficiently send the image pixel data over ROS. If you have a GPS on your robot, NavSat-Fix would be of use, as it displays latitude, longitude, and your covariances if they are available. There are also message types for laser scan if you have a single point LiDAR, or point cloud if you have a 3D LiDAR. IMU is of course if you have an IMU sensor giving you acceleration and orientation data about your robot. To include this in our code, simply call the sensor messages library and import any other message you are interested in that's mentioned in that list. And right now our linter is not updating, but if I just go ahead and save the file, we see the squiggly lines go away. Notice that the header file names will be snakecase. But when we call the message object in our code, it will be camelcase. So for example, if our hello world topic was instead expecting an image message type, I could write it out like so. And then of course, you'd be sure to change all the other declarations for this publisher to make sure they're of the image data type. But for now, I'll just go ahead and put it back to the string message type from standard messages. Keep in mind, if you use messages from the sensor messages ROS package, you'll need to make sure you include it as a dependency in your package.xml and CMake lists text file. So we add this like so. And be sure to add the dependency to the corresponding executable. Now, again, I am not going to actually compile this. I am just showing this as an example. So I'm going to go ahead and remove everything so it's back to the way it was. But hopefully you now have a better idea of how to implement different message types from different packages. You can also list what message types are available in your current terminal environment by running the ROS2 interface list command. Here we are given a long list which contains different message types from different packages. It's organized into three main sections: messages, services, and actions. Feel free to look through the different message types that are available. For now, let's review what we went over. In this lecture, we looked at ROS interface types. One of the things we learned is that we can use the terminal command ROS2 interface list to see what interfaces are readily available to us. And the output of that was separated into messages, which we can use for publishers and subscribers, as well as services and actions. And we look at the documentation for some commonly used ROS interfaces, such as the standard messages libraries, which has a collection of primitive ROS data types, as well as the sensor messages library, which has message types which are related to common sensors you may find on robotic systems. Now, there are tons of other interface types from other packages, and you can even create your own interface types. But for the most part, ROS gives us a large enough ecosystem of usable message types that we shouldn't have to make our own.